All right, guys, happy Friday. Here are your notes for today. So, here's basically what we're looking at. In Unit 5, we are talking all about polynomials. Just to give you a quick rundown of what that's going to look like this unit. In Section 5.1, we've got our introduction to polynomials. That's when we're going to learn all about what is a polynomial and how can we combine those using either addition or subtraction. So the homework for that day, which will be assigned to you today, Friday, November 3rd, will be due on Monday. Next, on Monday, we're going to talk about how you can multiply polynomials, which ends up being just lots of distribution. So, what we'll talk about how you can do that the long way using distribution, and then we'll look for some shortcuts if all you're looking to do is maybe expand some binomial. And we'll talk about what Pascal's triangle is and how that can help us. So that homework will be handed out Monday, be due on Tuesday for you. On Tuesday, we're going to start in on section 5.3, which is all about dividing polynomials. There's basically going to be two different ways that you can divide polynomials. One is known as long division, the other is synthetic. It'll probably take us a couple days to get through that. So plan on Tuesday and Wednesday talking about that and probably having some homework due either on Wednesday or on Friday of next week. And then our last section, as you can see, this is going to be a very quick unit, is going to be section 5.4, which is all about analyzing polynomial graphs. A lot of that will be review. A lot of that will be stuff that we looked at in Unit 1 that maybe we'll have to go over a little bit, but is stuff that you should have seen before. So what that kind of gets us to is that'll basically take us from next Friday through next Monday when we'll start to review. So we're basically looking at a test in about a week and a half, guys. It's kind of come up very, very quick. So on Wednesday, November 15th, that'll be when test is over this unit. Very, very short. Okay. So let's talk about polynomials and what a polynomial is. Here is basically what a polynomial is. It's an expression see if we can get the pen to work here. Well, we're almost there. It's an expression with multiple terms of various degrees. So, some examples of some stuff that would maybe look like a polynomial. You could have something like just a linear equation, like the example, maybe like something like 3x plus 1. If you were to have 3x plus 1, even though it's linear, technically that is an example of a polynomial. You could also have something that was quadratic, like you could have 4x squared, or even something that's much bigger, like you could have something like crazy x to the 7th minus, 5x cubed plus 2x minus 1. You could even just have a number, like the number 7 would be an example of a polynomial. So some non-examples, let's talk about stuff that would not be a polynomial. If you have anything with a square root, like the square root of x, would not be a polynomial. Or anything with a negative exponent, like x to the power of negative 3, would not be a polynomial. Also, anywhere there's a variable in the denominator, which we talked about our examples of rational functions, are not polynomials. And then also anything that would be exponential, so anything like 7 to the power of x, that would also not be a polynomial. So one of the things that we'll talk about when we talk about polynomials, we'll talk about what it means to have them in standard form. Here's basically what standard form is. It's basically a polynomial that's been written in descending order. Now, when I say descending order, what we're focusing on is the degree. It has to go down in the degree of each term. In other words, it would look something like ax to the power of n plus bx to the power of n minus 1 plus cx to the power of n minus 2, and then you could kind of keep that going, so on. An example of what that might look like. So, an example of a polynomial in standard form. You could have something like 3x cubed, well, 3x cubed, not 3x squared. 3x squared would have worked too, but let's do 3x cubed minus 2x squared plus 5x minus 4. So as you can see, The coefficient really doesn't matter, how you can go from 3 down to -2, back up to 5, back down to -4. What's important is the degree, how it goes from a degree of 3 to a degree of 2 to a degree of, it's not written there, but this would be a degree of 1. And then if you filled this in over here, it would be a degree of x to the power of 0. But we usually won't put the x to the power of 0 there. So when we talk about leading coefficient, what we need to kind of talk about there. Leading coefficient is the coefficient of the first term. So the coefficient of the first term in standard form. So you've got a polynomial that's written in standard form. Whatever that first number is, that first coefficient is, that is your leading coefficient. So for this example right here, where we had 3x cubed minus 2x squared plus 5x minus 4, the leading coefficient would be equal to 3. Okay, so there's kind of some of the basics. There is what a polynomial is. We've got some examples, some non-examples, and we've talked about both standard form and leading coefficient. Next, let's talk about this. Let's talk about how we will kind of give them some names. So you'll see that I'll kind of move quickly through this. If at any point you need to pause the video and copy some of this down, feel free to do that. So when we talk about classification, we do that in two ways. Similar to how in science class, if you were to name an organism, you list it by genus and species. Same kind of idea here. When we name polynomials, they get kind of a two-name system. The first name depends on the degree, the highest degree that you see. So it can go from everything from 0 up to a degree of basically any number you could possibly think of. Now keep in mind it has to be a non-negative number. So it's got to be 0 and up. So when you talk about 0, what we call that, if you have a degree of 0, we call that constant. An example of that would just be like a number. For example, 6. The number 6 would be the same as, and we kind of already talked about this, you could write 6x to the power of 0. Remember, anything to the power of 0 is 1, so that would just become 6 multiplied by 1 is 6. There is what it would look like to have a constant polynomial. Doesn't change, always just going to be a 6. Next, degree of 1, which is one that we are somewhat familiar with, is linear. So, as an example there, you could have something like 3x minus 2. And if it helps, you can put in a degree of 1 with the x. Don't need it, but that would be your example for linear. For 2, we should be very familiar with this one. We've spent probably close to the last month and a half talking about it. Degree of 2 gets a special name that is a quadratic. So, as an example there, you could have something like x squared minus 2x plus 1 would be an example of a quadratic. Next, you can also have a cubic. So if it's to the power of 3, think about a cube, you would have a cubic. As an example there, maybe something like 4x cubed minus 5x squared. Doesn't have to have all the terms going down. It didn't have to have like a plus 2x or minus 4. Doesn't have to have 4 terms necessarily. Next, let's talk about what is called a quartic. So what that will look like, as I'm sure you've already guessed, that would just be one where your degree was a power of 4. So something like 5x to the power of 4. There would be a quartic polynomial. Last one, and this is kind of where we run out of special names for them, is a quintic. As an example there, you could have something like 7x to the 5th minus 4 would be an example of a quintic. Anytime we get to be above 5, typically what we'll do, we'll typically just call it a polynomial with degree of 7, if it's a 7th degree polynomial, or a polynomial with degree 8 or degree 9 or whatever it ends up being. But once you get past 5, they really don't have any special names. Okay, so now let's start to talk about number of terms, which is kind of the second name that each of these gets. So, for number 1, if you have just a single term, what we call that a monomial. For those of you who, well, probably none of you were alive, but they used to have this term of mono, meant that the earbuds would they would have the same sound. It was just a single sound coming out of each of them. There wasn't like an alternating sound between the earbuds, but they used to call that mono. When they came out where it was alternating, they called it stereo. Now that's not the name for number of terms 2, but just to give you kind of some history there. Monomial and mono meaning one, there was just one sound. In this case, there's just one term. As an example, what that might look like, you could have something like 2x to the power of 4 would be an example of a monomial. Next, if there are two terms, think about a bicycle. You would have a binomial. Key thing there, your prefix of bi meaning 2. So that would be, as an example, maybe something like 3x plus 1. How there are two terms there, that would be an example of a binomial. So sticking with the bicycle example, if you have three terms then, that would be an example of a trinomial. T-R-I, tri. So that would be if you had like a quadratic x squared plus x minus 4, there would be a trinomial. And then if you have 4 or more terms, you would just say that it's a, for example, if it was cubic, it would be a cubic polynomial with 4 terms or with 5 terms. So you just say with blank amount of terms. You really don't have a special name. You could have a constant, well, you could have like a constant with 5 terms. You could have a quadratic with 4 terms. You could have a quintic with 7 terms. It really just kind of depends. But we just say that it's a polynomial with blank number of terms. Nothing special there. Okay, so let's do this. Let's talk about how we can classify polynomials. So 3 examples here. I'll work through one with you, and then my recommendation would be pause the video and see if you can get the other 2 on your own. So the first one here, where you've got 7x squared plus 3x cubed minus x. Make sure it's in standard form first. That's the first thing you need to make sure of. So in standard form, make sure the highest degree goes first. The highest degree you can see is a 3. So you would start with that term first. Make sure the sign stays the same, 3x cubed. Next highest degree I see is a 2. So the plus 7x squared would go next. And then for x would have a degree of 1 if you wanted to write it in there. So the minus x would go last. So now, looking at my polynomial in standard form. My degree, I've got a degree of 3. That would make this a cubic polynomial. For number of terms, I've got 1, 2, 3 terms, which would mean that the second part of the name I would give to it is a trinomial. So if you're looking to name this one, this would be an example of a cubic trinomial. And the leading coefficient, just whatever number is out in front of everything else, is the number 3 in this case. At this point, my recommendation to you would be to go ahead and pause the video, try the next 2 on your own, and then check to see if you're right. Alright, here's your chance to check yourself. So, on part B, here's what you should have had for standard form. Should have been 9x to the power of 4 plus 5x squared, and that was it. Because negative 3x and 3x added to be 0. So if you had those, just know that if you can simplify to combine like terms, you need to do so. So that's going to change your answer in another place too. Hopefully you still said that this was a quartic polynomial. But in terms of how many terms there are, in this case, you should have said binomial. So if you need to fix that, now would be your chance. For leading coefficient, probably still got that part right, would have been 9. Alright, last one here, where you had 5x plus 1. It was actually already in standard form for you. Wasn't that nice? For degree, it wasn't written. We can assume that it's a 1, so our degree would have been that this was a linear polynomial. And for number of terms, there were 2. That would tell you that this was a binomial. So, leading coefficient for this one ends up being 5. Alright, so let's talk about some operations we can do with polynomials. We're going to start by looking at adding. If you ever see this notation where it says f plus g of x, really all that's saying is take the 2 functions and add them together. In other words, take f of x and add it to g of x. So, don't get weirded out by that, just a different way of saying it. Here's what adding polynomials basically comes down to. It's all about combining like terms. In other words, if you look at example A here, where the first polynomial, negative 8x cubed plus x minus 9x squared plus 2, not in standard form, but really is not an issue at this point. What you want to look at is what is the highest degree, which in this case was a negative 8x cubed. We want to combine that with any other x cubes we see. So there's nothing else in my first polynomial. My next set of parentheses, my second polynomial doesn't have anything. My third one does. It has a negative 3x cubed. So when you combine those, negative 8x cubed and negative 3x cubed, you get a negative 11x cubed. Next, let's look for our next highest degree, starting with our first polynomial, which typically will just go down by 1. So let's look for all of our x squared. So we have negative 9x squared here, positive 8x squared here, and positive 4x squared here. If I add all those up, negative 9 plus 8 would be negative 1, plus 4 would become a positive 3x squared. Next, let's look for just plain old x's. So we've got a plain old x here, minus 2x here, and then nothing in the last one. So we would do positive x minus 2x would be a minus x. And then lastly, let's look for any constant terms. So we've got positive 2 here, positive 4 here, and minus 1 here. 2 plus 4 would be 6, minus 1 would be 5, so you would have a plus 5 at the end. Okay, so here's where that notation becomes kind of important, is in part B, where you see that you've got f of x equals 6x squared minus x plus 3, g of x equals negative 2x plus x squared minus 7. And it's asking you to find f plus g of x. So really what it's asking you for there, it's asking you to find what f of x plus g of x is. In other words, f of x, if we use substitution, was 6x squared minus x plus 3, plus g of x was negative 2x plus x squared minus 7. So now, let's look for some common terms. We've got x squared as our highest degree, so you've got a 6x squared here, a plus x squared here. 6x squared plus 1x squared is a 7x squared. Next, let's look for our linear terms. You've got a negative x and a negative 2x. Those would combine to be a negative 3x. And then lastly, you've got a positive 3 and a negative 7. Those would combine to get you a negative 4. At this point, here's what I would like for you to do. Go ahead and pause the video for a second, work through example C and D on your own, and then check to see if you're right in just a little bit. Alright, here's your chance to check yourself. Starting with your highest degree, you had a negative 4x to the fourth, and negative 3x to the fourth becomes a negative 7x to the fourth. My next highest degree, I don't have any x cubes in my first polynomial. In fact, I don't have any in my second. You don't want to write a plus 0x cubed. You don't need it. Instead, let's look to the next highest degree, which is a 3x squared. And I've got 3x squared and a negative 14x squared. Those would combine to be a negative 11x squared. And then let's look for constants now. So constants, I've got a positive 14, negative 8. Those would combine to be a positive 6. All right, let's check D now. So on example D, once again, it's asking you to find f plus g of x. So really all you're looking for there, f of x plus g of x. Nothing too fancy, just adding those together. So f of x would have been your 2x squared minus 4x minus 8. Plus g of x would have been negative x squared plus 2x plus 3. And now let's start to look to see if we've got some common terms that we can combine together. Starting with our highest degree. So starting with 2x squared. So 2x squared, negative x squared would combine to just be a positive 1x squared. Next, let's look at our linear terms. So we've got a negative 4x, a positive 2x. Those would combine to be a minus 2x. And then let's look at our constant terms. We've got a minus 8 and a positive 3. Those would combine to be a minus 5. Okay, so check yourself. C and D, C was negative 7x to the fourth minus 11x squared plus 6. D was x squared minus 2x minus 5. All right, we're almost there. Last thing we're going to talk about today. We're going to talk about subtracting polynomials. When you subtract polynomials, if it gives you this notation, f minus g of x, again, what it's looking for, it's really just looking for you to take f of x minus g of x. That is it. Now, what I will typically do, you can try to think about the subtraction as it stands. What I would do if you give me something like a, I like to just distribute the negative and say a negative 2x cubed becomes minus 2x cubed. A minus 4x squared would just become a minus 4x squared. A negative 3x becomes a plus 3x. That's where you need to be careful. and then a minus positive 1 just becomes a minus 1. I'm going to go ahead and copy in my first set of parentheses, negative 6x cubed plus 5x minus 3. And now I can just start to look to combine like terms. So highest degree is 3. I'm going to start by combining my negative 6x cubed and negative 2x cubed would become negative 8x cubed. Next, let's look for my quadratic terms, which it turns out there's only one. So really there's nothing to combine it with. You could just get to copy that down, negative 4x squared. Next, let's look at linear terms. You've got a positive 5x and positive 3x. Those would combine to be a plus 8x. And then lastly, look at your constant terms. You should have a minus 3 here and a minus 1 here. Gives you a minus 4. All right. Part B, very, very similar. Once again, you see the notation, f minus g of x, means that it's looking for you to take f of x minus g of x. So in this case, f of x was 12x minus 8x squared plus 6. Minus g of x was a negative 8x squared minus 3x plus 4. Once again, if it were me, and some of you might not need to do this, but I like to distribute, and I like to say negative 8x squared becomes a plus 8x squared. A negative 3x becomes a plus 3x. And a negative positive 4 becomes a minus 4. The rest, again, just copy down. 12x minus 8x squared plus 6. And then we can start to look for terms that we can combine. So, highest degree in this case was a 2, so let's start with it. Negative x squared and x squared are opposites. They'll add to be 0, you can just get rid of them. Next, you've got a 12x and a plus 3x would combine to be a positive 15x. And then lastly, your constant terms, you've got a 6 and a minus 4. Those would combine to be a plus 2. Alright, at this point, once again, I would suggest if it were me, just pausing the video real quick here, working through C and D on your own, and then checking your answer in just a little bit. Okay, here's what I'm hoping you did. So, a negative 2x squared becomes plus 2x squared. Negative 3x cubed becomes plus 3x cubed. A negative 4x becomes a plus 4x. And a negative positive 5 would just become a minus 5. And everything else in this case you would have just copied down from the first set of parentheses, so you would have just copied down your 2x squared minus 3x cubed minus 7. And now looking at these, my highest degree I see is a 3. So I've got a negative 3x cubed and 3x cubed. Similar to example B earlier, those will add to be 0. Next, I've got a 2x squared and positive 2x squared. Be careful, don't get too crazy canceling stuff out. Those will actually combine to be 4x squared. Next, look for your linear terms, in which case there is 1, just a plus 4x. And then lastly, look at your constants. You've got a minus 7 and a minus 5. Those would combine to be a minus 12. All right, and then for D, our very last example for today. In this case, you would want to take f of x and subtract g of x from it, in which case, let's see, that gives us x squared minus 3x minus 7, that quantity minus the quantity, negative x squared plus 2x. Once again, you'll see I like to distribute to both of my terms in parentheses to give me a plus x squared and a minus 2x. And then I just bring down everything else, x squared minus 3x minus 7. Now I like to combine like terms, so I get an x squared would add to become 2x squared. Then I've got a minus 3x and a minus 2x. Those would combine to be a minus 5x. And then lastly, look for any constants. In this case, I've got a minus 7 here. So 2x squared minus 5x minus 7. All right, so here were our goals for today. And I'm hoping you're seeing that this is what we did. We were looking to do the following: identify, classify, and evaluate polynomials. Did that kind of towards the start. and then combine polynomial functions by using addition and subtraction. So looking ahead to tomorrow, here's what we will be doing. Well, not tomorrow, but the next time I see you on Monday. We will be looking to multiply polynomials together. So we'll be looking at how do I take two polynomials and multiply using distribution. We'll also look at some stuff with Pascal's triangle. So that's what you can look forward to for Monday. For right now, that is it for notes today. Feel free to get a start on the homework assignment. Worksheet 5.1 should be posted on Schoology for you. Have a great weekend, guys.